Okay, this is the video walkthrough for the problems on your atomic mass of Candium Lab. Here we go. So you should have done this before some, so this is the same process. I'm simply going to take the mass of each isotope and multiply it by the percent abundance. So to begin with, we have lithium-6, which has a mass of 6.015. I'm going to multiply it by the percent abundance, which is 7.42%. So change that to a decimal, 0.742. That's going to give me an answer of 0.4463. And then isotope lithium-7 has a mass of 7.016, and I'll multiply that by its percent abundance, which is 92.58%, which as a decimal will be 0.9258, giving me 6.495. Then you simply add those together for the isotopes that you have. So I'll add those, and that gives me an answer of 6.942 atomic mass units. Okay, on to number 2. Now, number 2 is mimicking what you did in your lab. So you're not given a percentage in this. You're given the number of individual isotopes out of the total 200. So just to give you an example of what I'm going to do in this problem, the first one has 10 isotopes out of 200 atoms. So 10 of 200 is going to equal 0.05, which would be 5%. Now I'm not going to change it into a percentage because then I just change it back when we do the calculation. So what you have over here then is the mass of that isotope is 1.76.00, and I'm going to multiply that by 0.05. I'll change colors to keep this a little bit easier to keep track of. Then your next one is 38 of the 200 atoms, which would give you a decimal of 0.19. So then I'm going to take that isotope's mass, which is 177 atomic mass units, times 0.19. And I guess I'll just switch back to blue. We'll just alternate. No, I'm going to cycle to purple because it's so pretty. Alright, so your next isotope has 54. Makes up 54 of the 200 atoms of your sample. So it gives you a 0.27, or what would be 27%. So it's 178 AMUs for its mass, and we'll multiply by that 0.27. Then we have the next isotope has, make sure I'm in the right spot here, 28 of the 200, which gives us 14%, or 0.14 as a decimal, so 179 AMU times 0.14. And then finally, we have 70 of the 200 atoms of this isotope of hafnium are going to be of mass 180, and so and gives us 0.35, or 35% of it is the 180 hafnium times 0.35. And then again, the process here is simply to solve all these. So 8.8, 33.6, 48.1, 25.1, and 63, and then we add them all up, and hopefully we get something in between the low and the high, which means we're probably correct, and the answer ends up being 178.6 AMU. So again, something along those lines is where we get our percentages in the first place. Okay, moving on. Now, in number 3, it's just a question, no math required here. So you have bromine 79 and bromine 80. And what you need to do, as the hint tells you, is look and see what bromine's weighted atomic mass is on the periodic table. So if I look there, I find out bromine has a weighted atomic mass of 79.904 AMU. So the question then becomes, is it closer to 79 or 80? Well, 79.9 is obviously closer to 80. So the idea in a weighted atomic mass is it takes into account how much of one or the other you have. And so since we're closer to the bromine 80 isotope than the bromine 79 isotope, we must have more bromine 80. Okay, and then finally, the fourth problem is just another one with the mass and the percentages. We just have a lot more decimal places, but that doesn't change the process. So here we go. Let me get a different color. So the isotope of silicon that has a mass of 27.9769 has a percent abundance of 92, which will be 0.922297, and that will give us an answer of 25.80. And then the isotope with a mass of 28.9765 has a percent abundance of 4.7%. So as a decimal, that's going to look like 0.046832, and when we multiply that, it'll give us 1.357. And then finally, the isotope that has a mass of 29.9738 has a percent abundance of 3%, which is 0.030872, and that gives us 0.9254. And then again, once you multiply all of the isotopes masses by their percent abundance as a decimal, you add all of those together, and that gives you your weighted average atomic mass, which in this case is 28.09 AMU. And that is that for your atomic mass of candium. Hopefully you enjoyed that candy.